Okay, so our notes today are going to be over square root and cube root. Okay, so for our square root up here, we need to write the symbol for a square root. Square root has an understood 2 as the small exponent up here. We don't normally write it, but just know that in some cases, you'll see where they've actually written that 2. But overall, it's usually understood to be there. The square root is the inverse of squaring a value. So it would be the inverse of taking a number and squaring it. So whenever we try to find the square root of a value, we ask ourselves what number times itself, or what is the product of a number times itself that would give you what's underneath that radical. For the cube root, the symbol is that radical, but with a 3. That 3 will always be written. If it's any other type of root, it's going to have that symbol up at the top to tell us which type of root we're asking for. In this case, we're asking for a cube root. Cube is 3-dimensional, so we're talking about 3, something multiplied by itself 3 times. So an inverse of that is to cube a value. In other words, take it to the exponent of 3. Okay, now, these columns in this table are just to show us the pattern in squares and square roots, in cubes and cube roots. So we're going to take some time to fill those out. Okay, so,
You know the numbers these numbers up here?
yes,
On the calculator, it won't let you put that number.
this value here, how do you put it in the calculator?
I know how to do it, but it won't let you press enter now. It said error.
Show me. Oh, no, clear that out. It's what we just talked about earlier. Type in the root first, so you can do the third root, put a 3, second, and then the arrow key. No, the one above it. Press second again. Clear it. Press second. Okay, 3, second, the arrow key. Exponent key. 3, second, this button. That's for any other type of root. Can I see your calculator for a second? Okay, so what we just discussed, and I'm sure everybody needs a refresher on this. Sorry. Whenever you find the square root of a number in your calculator, the sequence of buttons that you press, the 2 is understood. It's never there. So if it's not there, you don't have to worry about putting in a number first. You're just going to find the radicals. So second, and you see it pops up on the screen. And then x squared, look above that number there, it has the root symbol. So then that's going to give you the square root of a value. And let's say we're finding the square root of 9, a number times itself that equals 9 is 3. Now, to find a cube root or any other type of root, which in 8th grade math we will only be finding square roots and cube roots this year. To find a cube root, because we have to place that 3 up there, it's a little different. We're going to type in the 3 first. We're setting it up to make it a small 3. Okay, so 3, and then second, but it's not a square root, so we can't use the x squared button. If you look above the x squared button, we have that exponent button, and you see that it has this little x with the root. Sorry, this one, the little x with the root. That's going to place the 3 in place of that x. Okay. And so now it's going to be a cube root or a third root. So when we press second and that button, you see it pops up and it's a small value now. So now we're finding the third root. Let's say we find the third root of 9. It's going to be a decimal. It's not perfect. And so the third root of 9, or the cube root of 9, is in between 2 and 3 because it's 2.08. Okay? So that's how we would use our calculator to help us calculate these. Okay, so there is also a button on our calculator that will help us square all of these values. Okay? It's that x squared button. You don't need to press second. So like for 1 squared, you press 1 and x squared, and you see it pops up the little 2 for an exponent. And so we need to put 1. 1 squared is just 1 times 1, which is 1. So we're looking at that pattern of squaring a value. Thank you. Okay, and so then 2 squared is just 2 times 2, which is 4. And 3 squared is just 3 times 3, which is... And 4 squared is 4 times 4, which is 5 times 5. 6 squared is 6 times 6. Thank you. 7 times 7. 49. 8 times 8. 9 times 9. And 10 times 10. Okay. And so that was going through and squaring each value. Now, if I'm trying to square root the value of 1, the square root of 1, well, we're asking ourselves, what times itself is 1? We're working backwards. It's 1. 1 times 1 is 1. Okay, now we're going to find the square root of 4. What's the square root of 4? 2, because 2 times 2 is 4. And then find the square root of 9. What's the square root of 9? 3. And so you see, when we find the square root of those perfect squares, we're getting those whole values that we multiplied together to get them. Okay? So the square root of 16, altogether, what is it? Square root of 25. Square root of 36. Square root of 49. Square root of 64. Square root of 81. And square root of 100. Okay, so that's the relationship between squares and square roots. Now let's look at the relationship between cubes and cube roots. 1 cubed is just 1 times 1 times 1, which is 1. And then 2 cubed is just 2 times 2 times 2, which is 8. And then we have 3 times 3 times 3. Thank you, 27. 4 times 4 times 4. 64. 5 times 5 times 5. Say again. And then 6 times 6 times 6. Seven times 7 times 7. Speak louder, please. Thank you. And then 8 times 8 times 8. And then 9 times 9 times 9. These are getting big, aren't they? And then 10 times 10 times 10. $1,000. Okay, so that's all the cubes. Now we can call them perfect cubes. Now we need to find the cube root of each one. Okay, so now the cube root of 1 is the cube root of 8. What do we multiply 3 times to get 8?
2.
The cube root of 27?
3.
3. The cube root of 64?
4.
The cube root of 125?
5.
It is. The cube root of 216?
6.
The cube root of 343?
7.
The cube root of 512?
8.
The cube root of 729?
9.
And the cube root of 1000.
10.
Okay. We're going to work with these so much that eventually you will have a majority of these memorized. But memorization of this is not as important as understanding the process of how you calculate it. Okay, so at the bottom we have a few examples to work through. Properties of exponents is what we were doing last week, and so it kind of blends into this week too, because a cube root and a square root do have similar properties as exponents. All right, so first, the square root of 121, we're asking ourselves what number times itself is 121? Okay, so it's 11, and that's because, so we're going to write the reason why. Because 11 times 11 is 121. Okay, now let's move over to this next example. We have the square root of 25 over 81. Now, the property of exponent says that whenever you have an exponent, it goes for the numerator on the outside of the fraction, it goes for the numerator, and separately it goes for the denominator. The same thing is true if you have a fraction under a square root. It means that you can split them apart into 2 separate problems. The top is the square root of 25, and the bottom you would take the square root of 81. So now we're asking ourselves, what number times itself is 25 for our numerator, which is 5, and what number times itself is 81 for our denominator? And that's because 5 times 5 is 25, and 9 times 9 is 81. So this would be our final answer. All right. Let's look at our next 2 examples. Our next 2 examples are for cube roots. Okay, so the cube root of 512, you can check that chart that we just made, or you could find the cube root in your calculator. The cube root of 512 is 8. And so we're going to write because 8 times 8 times 8 is 512. Okay, and the same exact rule applies for a cube root of a fraction. You take the cube root of the numerator separately and the cube root of the denominator separately. You do need to write the 3, otherwise it's going to be understood as a square root, and that's going to change the type of problem that we're asking. So what number times itself 3 times is 125? If you go back up to your chart, we have 5. And what number times itself 3 times is 216? 6. And that is our final answer. Okay, now, there are only 2 more pieces of information that we need to talk about. If x squared, or a number times itself, is 16, what number times itself gives you 16? 4. Okay, but is there another number times itself that will give you 16? There is one. Think about it.
16.
Has to be times itself. It's not 2, because 2 times 2 is 4. We're trying to get 16. Think about it. Well, it's a positive 16, right? What can I multiply to get together to get a positive? A negative times a negative, right? So what number can I multiply by itself also to get 16? Negative 4. So 4 times 4 is 16, and negative 4 times negative 4 is 16. So for whenever we find square roots, the square root of a number, there's going to be a positive and a negative version of it. So it's possible that there's more than one answer. So if I asked you what is the square root of 16, and it's not multiple choice, you're expected to be able to show that it could be positive 4 or it could be negative 4. Unless they're only asking for the positive or for the negative. All right, now, for a cube, so x cubed equals 729. To do the opposite, find out what number times itself 3 times is 729. Corey? 9. So x equals 9. Now, is there more than one answer for this one? Because you're multiplying it by itself 3 times, right? And a negative times a negative times a negative is still going to be a negative. And so that's not going to give, it's not going to be like the square root. It's a little different. Okay, so x cannot equal a negative number. It can't equal a negative value for a cube.